capacitance reading on these capacitors from this Anycubic power supply that has gone bad. This one's reading 318 microfarads. And this other one is reading 283, so they're way below spec. These are 470 microfarads, 250 volt. So these puppies are bad. With respect to the power supply, I did an earlier video and I started talking about a little more in detail with the machine itself. But in this video, I want to concentrate a little more on the quality of the board. If we look at the board, you know, one of the signs of a good board is proper soldering. This looks like a very clean board, so I am impressed with the layout. I was expecting to see an unclean board, maybe with some solder joints that were not properly soldered, but I can't see any flaws in that respect. So I think it's a good board. It's a good, it looks very well made. It's got good layout in all the parts. Seems to have decent filtering on the output side, which is the side that feeds the 12 volts DC. The input side, I can't say too much about the input side because this is looks like a filter on the input side. I've seen better filters. Better filtering done on some other power supplies, but you know, for the price that these things cost, I wouldn't expect too much. However, these are the culprits right here. These are the capacitors that have gone bad. And so I think if these were a little better quality, they would justify making this a much better power supply, considering what I just said about the PC board. It's very clean. It's well laid out, and I have no issues whatsoever with the layout or the PC board. In fact, it's pretty nice setup. These things are well insulated. And this has some silicone insulation here between the plates here and the metal case. I think I left those in my other bench where I do the soldering. This one has this little section here. This is a silicone, I believe, sheet here. So it looks like a nice power supply. It's got this cover right here, so I can't say too many bad things about it, except for these capacitors here, and these are the culprits. I mean, the machine itself, if we look at the Anycubic layout here, even the Tri-Gorilla boards are very nice boards. I did have one machine that I noticed when I opened it up that this heatsink had fallen off. And I have heard of people replacing these drivers with much better ones that improve the noise levels on the machine. The noise levels have never bothered me. I mean, the machines are fairly quiet, but I don't run these in my living room or bedroom, or as some hobbyists tend to do. I run these in a dedicated office, and I have a well ventilated area there, so these machines, as far as noise, have not been an issue to me. As long as you keep everything clean, you know, on the track, make sure that everything is aligned properly, you know, you can minimize some of those noise levels. However, the stepper motors do generate some noise, but like I said, it has never really bothered me that much. So I'm not too concerned with the noise levels of the machine. I'm more so concerned with the more important things that have to deal with the heating. Now, in my earlier video that I talked about, I went directly to the power supply, and somebody that may not know or is not aware of, I did go through the checking of the obvious things that you do have to check, such as the thermal resistor here, the one that senses the heat. That's got to be well seated there, as well as the heater element has got to be well seated there, so that you get true readings from the controller. So all that has been checked prior to me establishing that the culprit was the power supply. And sure enough, when you take those voltage measurements, that leads you to the issue with the capacitors.